There are usual workflows and construction processes when it comes to selection and procedures related to flat roof design. Flat roof design very often requires slopes of 2.5% in order for the water to run off. Upon roof design completion, the architect provides a layout plan so that the roofing contractor knows how the drainage of the roof will work. But when the design comes to a manufacturer's office, an already familiar problem is being recognized, where the design is simply not possible due to very basic geometrical rules. The roof is being built up from wedges in a fixed slope of 2.5%. When two wedges intersect in an asymmetrical joint, the edges of the wedges will not meet. Therefore, intersection joint of surfaces with identical slope must always be equal to the bisector of the angle of the parapet walls where slope is being directed to. To illustrate how flat roof design should flow by using Isover products, we are using a demo file with two different roofing scenarios. To begin, the Isover Flat Roof Designer plugin should always be installed. Links for downloading the application and registering an account can be found on the Isover Roof Designer website. In Revit, a dedicated tab should now be visible. Click on one of the three tools to open the plugin, and then log in using your email address and password. To begin the design, click on Load Families. This adds necessary elements to the project, including 3 component families for roof modification and 3 system families containing default roof type. The Materials family contains all the necessary product materials with correct thermal properties for the U-value calculation. Now, select the roof elements you want to design, and from the drop-down menu in the Properties panel, select the appropriate roof type. In this case, we choose Concrete. To edit the different layers in the roof element, go to Edit Type, and then press Edit. Here, you can see the different materials and thickness of the roofing layers. In the case of this demo, they remain unchanged. First, we will modify the top roof, which is currently completely flat with no inclination. To do that, go to the corresponding roof level and from the Architecture tab, click on Component Tool and select Saint-Gobain Drain Position RFA, which is a roof-based family. You can freely specify the desired position of a roof drainage element by hosting it to any surface of the roof you are trying to modify. After determining the drainage position, you need to identify the slope directions and surfaces. To make the initial roof inclination or main roof slope direction, once again, go to the corresponding roof level, set the top roof surface as the work plane, and then select New Family Isover Saint-Gobain Slope Volume RFA, which will be a wireframe template for roof modification. Be sure to use Place on Work Plane as the placement method, and then draw a line from the wall joint corner near the drainage position all the way up to the wall edge in the opposite direction of the roof slope. Optionally, you can drag the shape handles lengthwise to fill up the whole roof area. In 3D view, there is a new wireframe 3D element on top of our initial flat roof system family, which will generate a geometric relation which will be used to modify the roof in order to generate slopes of 2.5%. To modify the roof inclination, select Isover Saint-Gobain Slope Volume RFA and read out the roof line offset parameter value. Then, select the roof and click Modify Sub-Elements, after which you will select the roof edge you want to modify according to the wireframe volume. Enter Edge Offset, which you found under the Roofline Offset parameter. Press the Escape button on your keyboard to finish the command. The roof is now sloped towards the drainage position. Now we need to design our roof so the water will be redirected from the parapet wall towards the roof drainage. Again, in the roof plan, set the top surface of the roof, which is now inclined as a work plane. and then select Isover Saint-Gobain Wedge Volume RFA. Use Place on Work Plane as a placement method. Then draw a line from the wall joint corner near the drainage position all the way up to the wall edge in the opposite direction. Hit the space button on your keyboard to flip the family orientation if needed. In a 3D view, on top of the inclined top roof surface, there is a new 3D wireframe model which will be used as a template for roof modification. Since we want to subdivide our roof surface for further roof adjustments, we will use a reference plane to position our point for that purpose. Draw a ref plane in the direction parallel to our wedge volume, starting from the diagonal edge end on the wider side of the wedge as shown in the video. Select the roof and use Add Split Line to subdivide the roof surface in order to match the roof geometry with the wedge geometry. In the 3D view, on top of the roof system family, there is a subdivision line which will work as a hinge for roof modification. Select Isover Saint-Gobain Wedge Volume RFA and read out the roof point offset parameter value. Following the same logic as in the previous initial slope inclination, select a point on the roof geometry in order to match the wireframe settings, and then enter the roof point offset values you read. To verify that your roof is in the proper inclination, from Annotate tab of the ribbon, use the Spot Slope tool to annotate the slope angle. In our case, our annotation style unit format is set to rise 1000 millimeters inclination, which is of course equivalent to 2.5%. This brings both of our roof slopes in compliance with Isover specifications. Roof System Family's modification ensures that the wedge joints are never mismatched. Now, we will address the roof design of the lower terrace roof. We will position the drainage family near the corner of these walls on the roof surface. The slopes will be directed along the shorter dimension of the terrace segments. To start modifying the second roof, we need to go to the corresponding roof level and place Isover Saint-Gobain Drain Position RFA to the specified position. From the Architecture tab, click on the Component tool and use the already loaded family. As mentioned, we will direct the water flow along the shorter dimension of the terrace segments. This being said, select the top roof surface as the work plane. From the Architecture tab, click on the Component tool and use the already loaded Isover Saint-Gobain Slope Volume RFA. By drawing a line from the wall corner near the drainage position all the way up to the parapet wall edge in the opposite direction up the slope. Since our two roof segments are being inclined in different directions around the walls at the corner, we need to split the roof surface at the wall corner at an angular bisector, which in this case is 45 degrees. If the angle bisector is other than 45 degrees, you can draw a reference line at the correct angle, which would be used for subdivision. Since we already know our angle between the wedges, we can select the roof and use the Add Split Line to subdivide the roof surface by drawing a line in the 45-degree direction. In the Manage tab of the Revit ribbon, click Project Units and then Format button for the length parameter types. In the Rounding drop-down menu, use 3 decimal spaces. Hit the OK button in both windows. Proceed with the roof modification and read the roof line offset value, which is now showing 3 decimal spaces. When we perform the roof edge line offset, a temporary deformation will occur. As soon as we complete the process for the other roof side, the deformation will be corrected since we matched the geometry according to the 3D wireframe templates. What also needs to be done is to redirect the water flow from the walls towards the drainage position. Following the previous instructions in a corresponding roof plan, set the top surface of the roof as the work plane and then place Isover Saint-Gobain wedge volume RFA from the wall joint corner near the drainage position all the way up to the wall edge in the opposite direction. Repeat the process for the other roof segment by setting the roof surface as the work plane and placing the wedge family. Hit the space button on your keyboard to flip the family orientation if needed. To be able to subdivide the roof for modifications, as in the previous case, draw a reference plane in the roof level as per previous instructions and as shown in the video. The ref plane start point will be used as a snap point for the roof split line. Select the roof and use the Add Split line to subdivide the roof surface from the wall corner up to the ref plane start in both directions. The reference planes are no longer needed. Repeat the already described process of modifying the roof point heights at both roof corners to incline or redirect the water flow. Now that all roof modifications are completed, the Isover Roof Designer plugin should be used to verify that the roof elements meet the necessary flat roof design requirements. First, the roof slope validation is performed. Open the tool from the Isover Roof Designer tab and add the required roof elements to the project. This can be done individually, or else select Check All and press Add Roofs. Click the Validate button to run the verification. If all slopes in the project meet the required 2.5% slope, the tool will return a green validation mark beside the added roofs. If the validation fails, a red X will appear beside any failing roof element. The tool places a temporary identification pin on any surface that does not meet the required slope. A pop-up window lists the surfaces which fail along with a pin ID number. This can be used to navigate the 3D window to the exact location. Check the roof modification values on the failing slope and correct them. Any temporary pins can be deleted and the validation can be rerun. The next validation is the drainage area check. This allows the designer to verify that the drainage area for each drainage position meets the required maximum and minimum area values. Enter the required maximum and minimum values and press Validate. If the drainage areas are within the limits of those values, the tool will show a green validation mark beside the element name. If the validation fails, the tool will return a red X beside each failing roof element, and a pop-up window will list the specific roof elements and drainage points. A link with the ID can be clicked to highlight and navigate towards the element in the 3D view. The final tool helps the user ensure that an adequate thickness of insulation is chosen for the roof while factoring the length and the height of the sloped insulation wedges. The user enters the desired U value for the roof structure into the available field. Click Validate, and the tool generates a specific thickness in the yellow box. This value represents the thickness of insulation which is required in the roof structure underneath the slope wedges to meet the U value. A red X will appear beside any roof element which does not meet the insulation thickness requirement. This value corresponds to actual Isover product thicknesses that are available. In Revit, this is the same as the thickness of the variable layer of the roof assembly. As demonstrated earlier from the 3D view, select the roof and go to Edit Type and click Edit. Make sure the material of the variable layer matches that generated by the tool. In this case, it remains as the default Isover Robust Lamel. change the thickness to match the recommended value from the tool. Close this window and rerun the U-value check. All roof elements should comply with the requirements for flat roof design. Now, the height of the parapet wall can be modified as the total thickness of the roof structure is known. In a section view, the distance from the highest point of the roof element to the top of the parapet can be measured. This can then be lowered or raised depending on your requirements. In this case, we shall set the wall at 150 mm above the roof peak. Having a correctly designed parapet wall helps ensure no problematic or costly changes will occur later in the project. To get direct assistance from Isover Technical Service, use the Add to Project function. Here, you can enter basic information to help identify and distinguish between different projects. Click on Add Project, and the tool will confirm that it has uploaded files to the dedicated Isover web platform. These contain a 3D DWG file of the roof elements chosen in the plugin. The web platform can be accessed by pressing on the Profile Page button or from the Isover Roof Designer website. Now you can see the user dashboard with the project panel in the middle. Press Expand to see the project details which have been entered, as well as the 2 files which were uploaded. The file can be downloaded and viewed in AutoCAD. These files allow the Isover Roof department to see the roof elements being designed and offer feedback if necessary. To begin communication about a project, click the green Messages button on a specific project. In the Messages panel, you can write your message for that project and hit Send. The Isover team will promptly respond to your question to ensure your design goes exactly to plan.